In this tutorial, I will show you how to create a graph that shows you data over time from multiple treatments. And this is the type of analysis what we call repeated measures. And I will show you a little bit of how we summarize data using some functions in Excel. Now, if you open this data sheet, you might see this yellow bar at the top that says Protected View. Just go ahead and click Enable Editing. That way we can edit the worksheet together. Now, what I have given you is the growth of plants in various nutrient addition or fertilizer addition treatments: nitrogen, phosphorus, nitrogen plus phosphorus, and then my control of no fertilizer. I have 5 replicates for each fertilizer treatment. And what I want to do is graph the growth, the average growth per week for each of the treatments. And you can see that I have growth for the 5 replicates for nitrogen in week 1, the growth in week 2, the growth in week 3, the growth in week 4, and the growth in week 5. Now, I don't want to graph each individual point. I want to graph the average of this and the average of this, and the average of this, and the average of this, and then the average of this, and then I want to do that again for phosphorus, and then again for nitrogen, phosphorus, and then again for no fertilizer. You might be thinking to yourself, well, this is a great way for us to use a pivot table. Indeed, that's what we're going to do. We're going to say Insert, Pivot Table. Let's go ahead and select, or probably already did that on your end, but we're going to select all of this data. And let's put it into, in this case, we'll put it into an existing worksheet right here. Click OK. And now what we want to do is put treatment into rows. Forget about replicate. That was just for us to keep record of things. All we want in rows is treatment. Then you can either check or you can click and drag down, and you want to get all of the weeks measurements in there. Now you can see that the default for each of these is sum, and we want to change that to average. Go ahead and double click on each one of them and change to average. And now we are in the right place to start graphing our data. Let's go ahead and copy this out of the pivot table because we don't want to do the graphing within the pivot table. And we'll type in week 1, week 2, week 3, week 3, week 4, and week 5. Now the first step is to let's highlight the data for nitrogen and phosphorus. Click Insert, and then instead of our bar graph, we're going to click on this graph here, which is a line graph. Click on that, and then insert a 2-dimensional line. And then this is our data for nitrogen and phosphorus for weeks 1 through 5. Let's click and drag that over there, and let's right-click on the data and say Select Data. Now, the first thing that we want to do is edit this to say weeks 1, 2, 3, 4, and 5. So we can just say week 1, week 2, week 3, week 4, and week 5. Now we'll edit this, the series, and say N plus P. And let's go ahead and add the 3 other series to this graph. Our first series name, well, our second series name, sorry, is nitrogen. You could also just write N. Our series values are these values right here, which is J16 to N16. Let's add another series of no fertilizer. And our series values are going to be these values here for no fertilizer. And our series values for phosphorus are going to be J18 to N18, like that. And click OK, scroll over, and voila, we have a repeated measure style graph. Now you might notice that here it did reorder the ordering of the treatments here, and that's because it's just doing it in alphabetical order. Let's go ahead and give this graph a title and an X or a Y axis. So chart title above chart, we'll say plant growth over time. In the primary vertical axis, we'll just say growth, and I think I did in centimeters. And then, of course, let's add a legend so we know which treatment is which. Now, if you hadn't changed the series names, this would just show up as Series 1, Series 2, Series 3, and Series 4, but because we did, we can clearly see which line belongs to which treatment. The next part of this tutorial is to start summarizing data, so go to the Data Summary tab. And here is where we start challenging ourselves with the concept of variation. Now, if you recall from the lectures, for any data set that has a normal distribution, the average is right in the middle, and the variation is how wide this graph is. Let's go ahead and calculate the arithmetic mean, and then we'll also calculate something known as the geometric mean, the median, the mode, and the standard deviation, and as well as and the variance, and then the standard deviation. The arithmetic mean is the average, equals average, and then you select the data. We have 100 data points. Keep that in mind, we have 100 data points, and you should get an average or arithmetic mean of 20.25. The geometric mean is a little bit different. The geometric mean is the product of all of these values, so all of these values multiplied by each other, to the nth root. Just like we say to the square root, we say to the nth root. So you will do times, and then 1 divided by the number of replicates, which is 100. And that's saying to the 100th root, just like 1 over 2 would be to the square root. This is to the 100th root. You could also say, and check yourself, oops, my bad. Something was not times, but little caret to the nth root. You could also check yourself and type in geometric mean or geomean, and then just select all of the data, and you should get the same value. The median for our data set is the exact midway point, and all I need you to do is type in median, select the data, and that's the midway point. The mode is the most commonly found number. You can type in mode, and you should get 4. The variation is a little bit more challenging. The variation is the average squared difference of each point from its mean. In order to do this, we're going to use the arithmetic mean, not the geometric mean. The squared difference of 9 from the arithmetic mean is equal to 9, or B3, minus the arithmetic mean, G4, squared. Once again, 14 minus the arithmetic mean squared. You do that for each one of these data points, but if you do scroll that down, then of course we have to lock, and you can press F4, or you can type the dollar signs in. We have to lock G4. We scroll this down, and we get all of these squared differences. The variation is equal to the average squared difference. So it is tempting to type in average squared difference like that, and you would be almost correct, except We don't divide by the total number of replicates, rather we divide by the total number of replicates minus 1. And for a better explanation of that, you needed to have attended class. So we type in equals the sum of all of these differences divided by 99, or 100 minus 1. And we should get 3091. We can check ourselves by typing equals var and then select our data, which is the number of unique species in this, and we should get the exact same number. The standard deviation is just equal to the square root of the variance. Square root of the variance. And we can check ourselves here by typing stdev and selecting our data set. And we should get the same number. To recall, the standard deviation is the variation of the data set, but in the units of what we were measuring, whereas the variation is in the squared units of what we were measuring. Let's go ahead and do that for our second data set, tree height measurements. Once again, the average height should be 52.02. The geometric mean is equal to the product of all of these values to the power of the 1/100th root. The median, and of course we can check ourselves, geo mean. I encourage you to check yourself. Perfect. The median is the exact middle value. If we were to order this, 49, and the mode, in this case, there is a tie between two numbers, and so you might get something slightly different if you ordered this. I think you might get 4 or some other number if you ordered this. When there's a tie, Excel just goes with whatever the first most commonly measured response is. For our variation, we have to calculate the squared difference. So we type equals, and the first point is 17 minus the arithmetic mean squared. The second point is equal to 73 minus the arithmetic mean squared. And we can do this for all of them if we just drag it down, but of course we need to lock the arithmetic mean. We can drag that down. And now again, we want to calculate the variance, which is the average squared difference. And we could just type in equals average of the squared differences, but that's not going to be exactly right because it's, as I said before, it's not the average, it's equal to the sum of the squared differences divided by the number of replicates, which is again 100 minus 1, so 99. We can check ourselves by typing in var and then height, and we got the exact same number. Once again, the standard deviation is equal to the square root of the variance, and we can check ourselves here by typing in stdev, and sure enough, we got the exact same number.